Hello everyone, today we're looking at a new topic of graph transformation. In this specific video, we'll be looking at reflecting a graph about the x-axis. So now let's take a look at this figure here. If we name this figure f of x, right, and we reflect it about the x-axis, then this means that we are forming a reflection or a mirror image of this old graph about the x-axis. So you'd notice that if you are in this x-axis, these actually look alike, but the other one has been reflected, or rather it's a mirror image of the old one. So now we want to determine what the effect on the coordinates are, right? So what is the effect of reflecting a graph about the x-axis? So let's now first analyze what happens to the x value, because remember that in any, especially in a two-dimensional axis, we have only coordinates x and y. So we want to determine that what's the effect on x and what's the effect of y when we reflect a graph about the x-axis. So now, for instance, if we choose random points, let's say that we have x minus 1, minus 2, 1 and 2, right? So this is the old one and this is the new graph. Notice that here x on the old one was minus 1, right? And also on the new one, x was also minus 1. And here x was minus 2, and also here on this new graph x is minus 2. So if you do this on all the x values, you'd notice that the x values, when you're reflecting the graph about the x-axis, remain the same. So now the question is, what happens to the y value of the coordinate? So now, for instance, if we have a y value of 4, now the new value will be minus 4. So then now this tells us that if we have an original graph, then and we reflect it about the x-axis, only the y value will change, and it's only the sign that will change, because we had a 4 here, we also had a 4 here, but now it's a minus 4 instead. So now to write this in summary here, if we're doing a transformation of reflecting about the x-axis, then x will remain the same, but y will be negative of that value. So whenever we are given a graph f of x and we are asked to reflect it about the x-axis, what we need to do is we need to name a new graph g of x, right? And we need to make it equal to that old graph, however negative on the y value. So now if we look at this particular example, here they ask us determine the new equation of f of x equals x squared minus 9 reflected about the x-axis. So now we name a new functional graph g of x, and then we said we let it equal to that old graph, but we add a negative. So this is f of x, this is f of x, and we added a negative value. So when we distribute this, we'll have minus x squared. We distribute that, we'll have a plus 1. So this is the new graph reflected about the x-axis. So if you attempt to draw this, then this is how it will look. Here we have this graph, the old one. Notice that the y-intercept is on negative 9. So this is what we have on the old graph, f of x, right? This is how it's drawn. And now it's reflected about the y-axis. So we said that we'll just add a negative there, and then this is the new graph then reflected about the x-axis. Notice that if we try to draw this new graph, this is how it will look like. So now do you see that now we have a value of of 9 instead for the y-intercept, meaning that the y value did not change, only the sign changed from a negative 9 on the old one to a positive 9 on the new one. And now if we would look at, for instance, these x-intercepts, we said that the x value did not change. So do you see that the x-intercept on this specific graph has remained the same. So that's it for reflecting a graph about the x-axis. You need to just take out that if you have given a specific graph and are asked to reflect it about the x-axis, you just need to define a new graph, g of x, and add a negative, because we said that the y values become negative. So we add a negative of that old graph, and then we get our new graph that's transformed about the, or rather reflected about the x-axis.